Find the resultant of a vector of magnitude 5 units, direction 320 degrees, and a vector of magnitude 8 units, direction 0.55 degrees. When we talk of the resultant of two vectors, that means we are simply talking of that vectors which is the combined effect of the two vectors. We take solution. First step, we are going to start by representing this on a diagram. We have the first vector which has magnitude 5 units, direction 320 degrees. Let's draw our cardinal point. This is the north. 320, this is 90. Let's indicate the north. 90 plus 90, this is 270. That means 320 degrees will be here in this quadrant. Let's represent it. The vector is 5 units. This is the vector. So this angle from here to here, this is 320 degrees. Then this angle here will be one complete revolution is 360 degrees. So this angle here will simply be 360 minus 320 degrees. And this will give us 40 degrees. If from here to here is 320, then this angle will simply be, we are going to take 90 minus 40, which gives us 50 degrees. So this is for the first vector. And we have been told that this vector is 5 units of magnitude. The second vector is of magnitude 8 units in the direction of 0.55. Let's represent the second vector. Start by drawing our cardinal point. This is the north. 55 degrees lies in this quadrant from the north. Represent the vector, which is of magnitude 8 units. This is the vector, so of magnitude 8 units. This angle is 55 degrees. Then this angle here will simply be, we take a 90 degrees minus 55 degrees, which gives us 35 degrees. This angle will simply be, you said this and this are alternate, so they will be the same, 40 degrees. If this is 40 degrees, then this angle here must be 50 degrees. The resultant vector moving from this point, let's call this point O, to this point A, then to this other point B, O, A, B, the resultant will simply be from O to B directly. this is 5 units, 8 units. We need to find the magnitude of OB and the direction of OB. For us to get the direction of OB, it will simply be this angle from the north. We are going to call this angle theta. Now, by making use of the cosine rule, by using the cosine rule, we can find the magnitude of the resultant vector, that is OB. We can find OB by making use of the cosine rule. OB squared will simply be equal to OA squared plus AB squared minus, we take 2 times OA times AB times the cosine of the angle OAB, the cosine of this angle. So this will give us OB all this squared to be equal to OA squared plus AB squared minus 2 times OA times OB times the cos of OA cap B, this angle. This will simply be equal to, inserting the numerical values, OA is 5 units, so this will give us 5 squared, plus AB is 8 units, 8 squared, minus 2 times OA, which is 5, times OB, which is 8, times the cosine of the angle, 85 degrees, because when you take 50 degrees plus 35 degrees, it gives you 85 degrees. So this will be equal to 5 squared, which is 25, plus 8 squared, which is 64, minus 2 times 5 gives us 10 times 8, which is 80, times the cos of 85 degrees, which is 0.087 to 3 decimal places. This will be equal to 25 plus 64. It gives us 89 minus 80 times 0.087. This gives us 6.97. This will simply be equal to 89 minus 6.97. It gives us 82.03. Next, we have to take square root on both sides. The square root of OB, all this squared will be equal to the square root of 82.03. Then OB will simply be equal to, we take the positive square root of this. So 2 decimal places gives us 9.06. Then OB will simply be equal to, let's give this to 1 decimal place, it gives us 9.1 units. So this is the magnitude of the vector OB. That means from O to B, this will be 9.1 units. Next step, we have to find the direction. For us to find the direction of this vector, we are going to make use of the sine rule. We know this angle, we know this side, we know this other side, we know this other side. Then this angle will simply be 40 degrees plus theta by using the sine rule, we can find the direction of the resultant. That is, if we take OB all over, this is OB over the sine of this angle over the sine of OA cap B, it will be equal to, we take AB all over, this is AB, all over the sine of this angle, all over the sine of B, O cap E. Then OB, which is 9.1, all over the sine of OA cap B, 35 degrees plus 50 degrees, which gives us 85 degrees. It will be equal to AB, which is 8 units, all over the sine of BOA. This is BOA. This will be 40 degrees plus theta. The sine of 40 degrees plus theta. Next step, we are going to cross multiply. Then 9.1 times the sine of 40 degrees plus theta will be equal to 8 times the sine of 85 degrees. Next step, we have to simplify. We have to divide both sides by 9.1. Then 9.1 times the sine of 40 degrees plus theta. We divide this by 9.1. It will be equal to 8 times the sine of 85 degrees. We divide this by 9.1. At the left hand side, 9.1 will strike on 9.1. Then the sine of 40 degrees plus theta will simply be equal to 8 times the sine of 85 degrees. Divide this by 9.1, it gives us 0.876 to 3 decimal places. Then, taking sine inverse for both sides, 40 degrees plus theta will simply be equal to the sine inverse of 0.876. This will give us 40 degrees plus theta to be equal to the sine inverse of 0.876 to 1 decimal place gives us 61.2 degrees. We have to look for theta. We are going to transfer 40 degrees to the right, which becomes negative. Then theta will be equal to 61.2 degrees minus 40 degrees. This will give us theta to be equal to 61.2 degrees minus 40 degrees gives us 21.2 2 degrees, of which this is approximately 21 degrees. Then we conclude, therefore, the resultant vector is of magnitude 9.1 units and direction 0.21 degrees. We are done with the solution of this question. If in case you have any doubts, feel free to drop your questions at the comment section. Please like the video, share, and subscribe to this channel. Thank you very much for watching.